Hi all. In the previous table I did alpha by 2 because thinking that my t table is one-tailed, but I have the table of two-tailed test, so we will not do alpha by 2. So t distribution t table we are going to see at n minus 1 degrees of freedom, that is 10 samples we are having now. Sample size is 10, weight of 10 students. So 10 minus 1 9, and alpha level of significance is 0.05. Yeah, 0.05. Therefore, we'll see the table. At 9 degrees of freedom, yes, at 9 degrees of freedom, 0.05, it is 2.26. So we'll write here 2.26, 2.26, right? Thus, the 95% confidence limits are limit are x bar plus or minus that t from the table n minus 1 alpha, and here we are having s by root n, standard error, plus or minus standard error is there, no? So this is what. So x bar plus or minus t into standard error, or we can write x bar plus or minus t, this is from the t table, into standard error. So this is n minus 1 alpha. Come on. Okay, so now s by n will calculate, s by root n, not s by n, standard error. So we'll try to calculate the standard error. Standard error is what? S by root n. Okay, what is s? S we got as 11.79. Okay, standard deviation from here. See, 11.79 approximately, right? So 11.79 standard error by root n. Root n means root 10. This also we will calculate from here. Equal to divided by root n. So same way, SQ square root of 10. Okay, so what I calculated is 1179 divided by square root of 10. Okay, I got the answer as 3.729. I'll make it bigger. Now you can see 3.729. 3.73 we can take 3.73. Okay, 3.73. 3.73, which is equal to 3.73. I think I'm right. 729, no? 3.729, 3.73. Okay, 3.73. We got a standard error. Now we have to substitute in the formula. What is the formula? X bar. That is confidence, 95% confidence limits we are finding. What we are finding is 95% confidence limit. X bar is 63. Okay, we calculated now, you remember? X bar. Mean is 63, right? I'll make it bigger. Okay, mean. Okay, mean is 63. So that is what we are writing. Mean is 63 plus or minus. What is tabular value? Tabular value is 2.26 t n minus 1 alpha, that is 2.26 okay, t tabular value into standard error. Standard error we got as 6.73. Okay, this is what standard error we got. So we'll calculate from the Excel. Okay, 63 plus or minus 2.26 tabular value into standard error. Standard error we got as 3.73, right? We go back here, equal to 63, okay, plus we'll take first, plus 63 plus 2.26 into 2.26 into 2.26 into 3 point this one, standard error. Okay, what we got? 71.43. Okay, upper limit is 71.43. Upper limit. We'll find lower limit equal to, we have to minus, right? It is same, but we have to subtract. Control C. Control Z. Enter. Equal to Control V. We'll make it as minus. Shall I make the cell size bigger? Okay. Cell size bigger. Okay. What it is? 63 here. 63 plus 2.26 into H7. H7 is for standard error. It is 3.73. Right? This upper limit, lower limit is 54.7, 54.57. 54.57. Okay, that's all. Upper limit, lower limit we got. Hence, required require 95% confidence interval for the average height. For the average height no, we are talking about weight, sorry. Average weight, we are writing in kgs now. Confidence, therefore, the required 95% confidence interval for the average weight of students. This population weight lies between in this interval, okay, of students of study center is given by what is the lower limit? 54.54, okay, 54.57 lower limit, comma upper limit is for 71.43. Okay, we can take open interval better. We'll take the open interval. Okay, so that is 54.57 or 71.43. The average, actually population weight. Okay, population average weight lies in this interval. Okay, population average weight of students in study center lies in this interval. That is what the conclusion is all about. Now we go to the next topic. The next topic is uses of ANOVA. Before studying about uses of ANOVA, first we'll try to learn about the t-test. Okay, then only we'll understand about the ANOVA. Suppose all this, whatever we have seen before, or everything is about the t-test only. Probably if you don't understand, I will teach again. T-test. Okay, suppose there are two groups, G1 and G2. Okay, and G1 and G2 are one is known as the experimental group, another is known as the control group. Suppose experimental group students are learning through new method of teaching. And this group is learning through old method. You want to find whether the new method is better than the old method. That is what I exactly want to find. So these students will learn for say 5 months using the new. G1 will learn using new teaching method for suppose 5 months, and the G2 is learning the same whatever they are learning now, for example polynomials. Okay, the topic is polynomials. Okay, G1 is learning polynomials. 5 months is too much. 1 month will take. So G1 will learn polynomials for 1 month using the new teaching method, and G2 will learn the same topic polynomials using the old teaching method for 1 month. At the end of 1 month, the test is given to G1 and G2. So their average mark is calculated. Suppose their average mark is x1 bar and this average mark is x2 bar. Again, and we are talking about the population. This is samples mean and this is also sample mean. But its population mean is mu1 and this population mean is mu2. So hypothesis is framed on the population mean only. Okay, because we are going to estimate about the population only, population mean. Okay, estimator, x1 and x2 are estimator, and ultimately we are going to estimate about the population mean. What is the population mean? That is what we are going to find or we are going to estimate. So H naught, the null hypothesis, we can say that there is no significant difference between mu1 and mu2. This is null hypothesis. H1 you will frame that there is significant difference between mu1 and mu2. Their mean is not equal. There exists significant difference. So hypothesis you are framing now between the two groups. So if there are two groups, we are supposed to use the t-test. Suppose there are 3 groups or 4 groups. So we'll take the example of 4 group. Suppose one field is there. Okay, you are dividing the field into 4 parts. Okay, so P1 I am using only water, nothing else. And P2 field, this is field. Okay, it's field. There is one field. I suppose I am having one field. I am dividing the field into 4 equal parts, and I want to test whether the fertilizer I am using is good or not. For that I am checking. So what I do is I do the research. So I divide the field into 4 parts. Field 1 I am using only water. Okay, and field 2 I am using the new fertilizer. Right, and field 3 the old fertilizer which I was using before, the same fertilizer I am using. So I want to find is there any significant difference, the new fertilizer which I recently purchased and the old fertilizer which I was using before, and P4. This P1 sorry P2 and P3 are chemicals, right? P4 is compost. I am using the compost. So I want to check whether only water is enough for my field,